SpongeBob SquarePants. 7.3 Similarity Theorems. All right, so these theorems are going to look a little bit familiar because we've looked at the same names before, but these theorems are actually different in what they say, so pay close attention to their words. Angle-angle theorem. Angle-angle similarity theorem. We actually haven't seen an AA theorem yet, but these theorems are to show that two triangles are similar, not congruent, similar. All right, the theorem says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So if I ask you if these two triangles are similar, all you have to see is if you can match up two angles. Let's do a couple of examples. Like this one. Are these two triangles similar? Well, it looks like these two angles match up, so that's good. But we need two pairs to match up, not just one. Well, what about the 45? Does it match up to this? Well, if you use a triangle sum theorem, 105 plus 30 plus 45 equals 180, it turns out that these two guys do match up. So we do have two pairs of angles. And even if you try to find this angle right here, it turns out that that angle is 105. So in fact, we're going to get three angles. But the theorem says two pairs is enough. So this one is yes. They are similar. Oh, by the way, that is the symbol for similar. It's like a squiggly line. What about these two triangles? Are they similar? Can we find two angles that match up? Well, most of you guys know that vertical angles, you can always mark them. So we have one pair of equal angles. Do we have another pair? Well, if you notice, these little arrow thingies means something, and we've studied them before. Whenever we have arrows, that means we have parallel lines, and whenever we have parallel lines cut by a transversal, we got a ton of vocabulary words. And it turns out that because those lines are parallel, these two angles are equal. They're alternate interior angles. And so when you have parallel lines, you are allowed to mark those, and so that gives us angle, angle. All right. Are these two triangles similar? All right, so this one, I draw one triangle inside of another triangle. And so if it helps and you want to, you can actually separate them so that you're dealing with two separate triangles, because sometimes it's kind of hard to picture one inside the other. All right, let's see if we can find a pair of angles that match up. It turns out that, again, there's these two famous parallel lines again. So whenever you have parallel lines, there's a few things you can mark. These are corresponding angles. You can mark those. And then same thing over here. Also corresponding angles. You can mark those. But there's actually a third one. And again, we don't need the third one, but it turns out that they both share angle T. And remember what happens when they share it? We call that reflexive property. All right, so this one does work out for angle, angle, two angles matched up. And so we have similar triangles. Here's another theorem. Now this one is side-side-side theorem, which we learned a couple of chapters ago, but this is the side-side-side similarity theorem. All right, and it says a little bit different than the other one. If the corresponding sides of two triangles are proportional, then the triangles are similar. So what you have to do is, it used to be like match this side to this side and you're good, but it's not that theorem. The similarity theorem is different. It says that this side has to be proportional to this side as it is to this side as it is to the third side. All right, so let's see what that means right now. Looking at those three triangles, which two are similar? Well, we're going to go ahead and just compare two at a time. Let's work with these two. Let's take side 6 and compare it to side 4. 6 to 4. Reduce it. Always reduce your fractions. Let's go ahead and compare side 14 to side 8. Oh, I didn't do 14 and 8. I did, instead, I did 10 and 6 and reduced it. And it looks like they do not reduce down to the same scale factor. So those two triangles are not similar. Let's go ahead and compare, I don't know, let's compare these two now. This side 4, compare it to side 6, reduce it. I think I did 8 and 12 next. Oh, I didn't. I did 9 and 6, these guys. And they do reduce down to that number. And then I did 8 and 12 last. And guess what? They all reduce down to the same scale factor. So it turns out that these two triangles are similar, not this one. All right. And then our third and final similarity theorem for the day, side, angle, side. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. Oh my gosh, what does that mean? All right, so what it means is, if you can find one angle, let's say angle X and angle M, let's say that they are equal to each other. That's one step. Then the side, if you take that and you compare it to that, and then you take this side and compare it to this side, and if they're proportional, then you have similar triangles. Let's do an example. All right, here we have two triangles. Notice that these lines are not parallel. There's no little arrows. So when it's not parallel, then these guys are not equal. These guys are not equal. So you cannot use angles. See, those parallel lines are important. But we do have this angle and this angle. Vertical angles you can always mark. But let's go ahead and compare the sides. Let's compare 64 over 72. Reduce it to 8 over 9. Now let's compare the 40 to the 45. Reduce it, and look at there. The sides match up now. So we can say that this triangle is similar because of side, angle, side. All right. Here's one that requires you to do a little bit of algebra. I tell you that these two triangles are similar, so now we can use some of the properties of proportionality. Solve for x and y. We'll do one at a time. Let's do the x. The x matches up with the 5. How did I know that? Well, if you look at side AB in the given, here's AB, it has to match up with DE in the order that I give it to you. And so that's why it's DE. Oh, and then the other match is the 16 matches up with the 7. All right. And again, you have to be consistent. If you're going to go from big to small, then consistently go big to small. All right, so there's our setup. Let's go ahead and use some cross multiplication and then use basic algebra to solve. It turns out that x equals 52 over 7. Let's do the same thing for y. All right, so here's y minus 2. We have to match it up to the 12, and that should equal 7 over 16. Notice in this problem, I went from small to big, small to big. All right, use your Algebra 1 skills. Cross multiply, distribute, simplify. Y equals 116 over 16, but always reduce it, 29 over 4. Ooh, a word problem. So I used to do this activity with my classes where we would try to find the height of the flagpole in front of the school. All right, and so it requires a lot of work, but I basically set it out as a tiny little word problem. We have a student. He's 4.1 feet tall. He's standing away from a point that is 6.3 feet away from him. And then the distance from him to the lamp post is 27.8 feet. If you try to extract some similar triangles from this picture, we do have something that looks like this. All right, again, two similar triangles. And so we can use proportions to set up an equation and solve. X right here is the height of the lamppost. We're going to go ahead and compare the x with the 4.1. And then here's the tricky part. It's the whole bottom compared to this guy. All right, so be careful. X compares to the 41, but it's the whole bottom of the big triangle. The 34.1 compares to the 6.3. All right, be careful with that. Cross multiply, solve it out. The flagpole, or in this case, the lamppost, is 22.19 feet. All right, that is all. Go ahead and try the homework.